In the silent, unending theatre of the cosmos, there are stories written in light and gravity. Some are epic tales of creation unfolding over billions of years. Others are quiet chronicles of celestial solitude. And some are cosmic ghost stories, mysteries that haunt our telescopes and challenge our understanding. For decades, we have turned our gaze toward a particular point of light, a star that seems deceptively simple, a solitary beacon in the autumn sky. Its name is Fomalhaut, the lonely fish, a bright, youthful luminary just 25 light-years away. For generations, it was a familiar friend, a reliable fixture in our celestial neighborhood. But we are learning that even our closest neighbors can harbor the most profound secrets. Humanity's newest, most powerful eye has now stared into the heart of Fomalhaut's domain, and what it has sent back is not a simple portrait of a star system. It is a portrait of a haunting, a riddle wrapped in dust and light, a spectacle of complexity so bewildering it has sent shockwaves through the astronomical community. This is the story of a phantom world, a cosmic crime scene, and a system of impossible rings. A narrative that begins with a celebrated discovery, descends into baffling mystery, and now re-emerges as one of the greatest puzzles the James Webb Space Telescope has ever uncovered. To truly grasp the magnitude of this revelation, we must first journey back in time, not merely to the dawn of space exploration, but to the very genesis of human curiosity. Fomalhaut has always been with us, a piercing blue-white diamond against the velvet black. Ancient Persians considered it one of the 4 royal stars, a sentinel of the heavens. Its Arabic name, Fum al-Hut, means mouth of the fish, a celestial landmark for navigators and dreamers. For millennia, its light traveled across the interstellar void, carrying a simple message, "I am here." But that light carried so much more secrets locked in its spectrum, stories hidden in its subtle glow. It wasn't until the late 20th century that we began to decipher these cryptic messages. Astronomers using the infrared astronomical satellite in 1983 detected a surplus of infrared radiation. This was not the light of the star itself, but a cooler, fainter glimmer. It was the telltale signature of dust, a vast, cold disk of debris encircling the young celestial furnace. This was a monumental finding. It was the first circumstellar disk ever resolved around another star. We were looking at the raw material of creation, a nascent solar system in the making, a cosmic construction yard filled with the pulverized remnants of comets and asteroids. Fomalhaut was no longer just a star. It became a laboratory for understanding our own origins. Then in 2008 came the bombshell announcement. The Hubble Space Telescope, our steadfast eye in orbit for nearly 2 decades, had done something extraordinary. It had taken a direct photograph of a planet outside our own solar system. There, on the inner edge of that colossal dust belt, was a tiny, faint speck of light. It was designated Fomalhaut b, and it became an overnight sensation. The first exoplanet ever to be visually confirmed, a poster child for planetary discovery. We saw it with our own eyes, a world in orbit around another sun. The implications were staggering. This was not an indirect wobble, not a subtle dip in starlight. It was a photograph, a tangible piece of evidence of another world. Scientists celebrated. The public was captivated. We imagined what Fomalhaut b might be like, a gas giant, perhaps larger than Jupiter, a lonely sovereign patrolling the frigid outer reaches of its system. We had found a new world, and it felt like a turning point in our cosmic exploration. But the universe rarely offers up its truths so easily. Fomalhaut's ghost story was just beginning. Almost immediately, the planet began to behave strangely. It was an orbital enigma, a celestial nonconformist. Its path around the star was wildly eccentric, a long, looping trajectory that defied neat explanation. This strange orbit would carry it plowing directly through the immense dust belt. A journey so perilous it seemed almost suicidal for a gravitationally bound world. Furthermore, there was another deeper puzzle that troubled astronomers. For a planet massive enough to be seen in visible light, it was perplexingly dim in the infrared spectrum. Giant planets, especially young ones, should be warm, glowing with the heat of their formation. Fomalhaut b was cold, almost invisible to infrared telescopes. It was a contradiction, a scientific paradox. How could a world so large be so frigid? How could it shine so brightly in visible light, a light that was likely reflected from the star yet possessed no intrinsic heat of its own. The questions piled up, and the beautiful, simple picture of a new planet began to crack. The scientific community entered a period of intense debate. Theories were proposed, models were built, but none could fully reconcile the bizarre characteristics of this object. Fomalhaut b was becoming less of a planet and more of a riddle. Then, over the course of several years of patient observation with Hubble, the mystery deepened into outright bewilderment. The dot of light was changing. It was expanding, growing fainter, spreading out like a dissipating puff of smoke. Planets do not do this. Worlds are gravitationally bound. They hold themselves together with immense force. They do not simply dissolve into the vacuum of space. The evidence became undeniable. By 2014, the celebrated Fomalhaut b had vanished entirely from view. The first exoplanet ever directly imaged had performed a cosmic disappearing act. The conclusion, when it finally came, was as stunning as the initial discovery. Fomalhaut b was never a planet at all. It was a ghost. What Hubble had captured in 2008 was not a solid world, but a transient, expanding cloud of fine dust. A momentary apparition masquerading as a planet. The leading theory now paints a picture of immense, unimaginable violence. Sometime shortly before our first observations, two large celestial bodies, perhaps icy planetesimals hundreds of kilometers in diameter, collided with cataclysmic force. Imagine the scene. Two frozen worlds moving at tens of thousands of kilometers per hour on an intersecting course in the dark. For eons they had orbited Fomalhaut in solitude. Then, in a fleeting moment of cosmic violence, their paths crossed. The impact would have been silent but absolute. Not an explosion of fire and sound, but a pure kinetic release of energy on a planetary scale. The two bodies would have shattered, vaporizing into a cloud of ice, rock, and dust. An ethereal shroud of debris expanding outward from the point of impact. It was this ephemeral cloud, this aftermath of a cosmic catastrophe that Hubble had seen. Its brightness in visible light was due to the vast surface area of fine dust particles scattering the light from Fomalhaut. Its dimness in the infrared was because the particles were tiny and cold, not a large, warm planet. Its expansion and subsequent fading was the cloud simply dispersing into space its destiny to become a faint, indistinguishable part of the larger dust belt. The case of the phantom planet was closed. Fomalhaut b was dead because it had never truly lived. It was a temporary monument to a magnificent collision, a cosmic tombstone that fooled us all. The story, it seemed, was over, but it was only the end of the first act. Enter the James Webb Space Telescope, a new detective on the scene, an instrument of unprecedented power and sensitivity. With its immense 6.5-meter golden mirror and its exquisite infrared vision, JWST was designed to see what Hubble never could. It can peer through clouds of dust, capture the faint heat of distant objects, and resolve details with breathtaking clarity. Astronomers turned this powerful new eye toward Fomalhaut. They weren't looking for the phantom planet. They were hoping to study the famous outer dust belt in greater detail. What they found has rewritten the entire story of the Fomalhaut system and presented us with a puzzle far more profound than a disappearing planet. The images that came back from Webb were simply astonishing. They did not just show the known broad outer ring of debris. Instead, they revealed a system of breathtaking complexity, a nested structure of concentric rings that had been completely invisible until now. Like ripples in a cosmic pond, a series of ethereal girdles of dust encircle the star. Let's pause to fully absorb the spectacle that JWST has unveiled. This is not a single simple ring of debris like our own asteroid belt. It is a grand architectural marvel sculpted by forces we are only just beginning to comprehend. The outermost belt, the one we knew about from Hubble, is now resolved with stunning precision. It is revealed to be shepherded by an outer unseen planet, its gravity corralling the dust into a relatively narrow band. But inside this familiar structure, Webb's infrared gaze uncovered a ghost, a faint but distinct intermediate ring. A belt of cold dust that had evaded every telescope before this moment. Its existence immediately poses a problem. What is holding it in place? Another unseen planet must be patrolling this region, its gravitational influence carving out this delicate feature from the primordial disk. And then, closer still to the star, Webb found something even more surprising. It detected what scientists are calling the Great Dust Cloud. This is the vastly expanded, now incredibly diffuse remnant of that ancient cataclysmic collision that created the phantom of Fomalhaut b. The cosmic crime scene is still there, its ghostly echo smeared across billions of kilometers of space, a faint haze of pulverized world stuff. The sheer scale of this system is difficult to process. The outermost ring is 150 times farther from Fomalhaut than the Earth is from the Sunday. The entire structure spans a staggering 23 billion kilometers. We are looking at a system shaped by a history of both quiet formation and staggering violence, a place of both elegant architecture and chaotic disruption. And it is this duality that makes the JWST discovery so profoundly shocking. The presence of these delicate nested rings suggests a system governed by the subtle, persistent gravitational nudges of multiple stable planets. Yet the evidence of the Great Dust Cloud tells a story of instability, of world-shattering impacts. How can both be true? How can a system be both a pristine, sculpted masterpiece and a chaotic demolition site? To understand the forces at play, we need to use an analogy. Imagine a perfectly still circular pond on a windless day. The surface of the water represents the primordial disk of gas and dust that originally surrounded the young Fomalhaut. Now imagine a large, heavy stone is dropped into the very center. This is the star itself. The gravitational pull of the star organizes the primordial disk into a relatively flat, rotating sheet. Now let's introduce a planet. Imagine a person walking slowly in a perfect circle within the pond. This person represents an unseen planet, and their movement creates waves. As they walk, they generate a continuous ripple that moves both inward and outward. This ripple is an analogy for the planet's gravitational influence. It doesn't just pull on the things next to it, it sends out waves of influence through the entire disk. These gravitational ripples can push dust and debris around. Over millions of years, a planet's steady, rhythmic gravitational disturbance can clear a gap in the disk, like its weight clearing a path in the water. It can also pile up material at certain stable distances, creating rings. This is the process of shepherding. The existence of the multiple distinct rings seen by Webb strongly implies the existence of multiple unseen walkers in the cosmic pond. Each ring is a gravitational echo of a hidden world, a planetary shepherd sculpting the dust with its invisible hands. The Fomalhaut system, once thought to be a simple star with one big ring, is now revealed to be a complex multiplanetary system. At least 2 and possibly 3 large planets must exist there, their orbits perfectly placed to create the nested structure that Webb has so beautifully revealed. These are not small worlds, they are likely gas giants with masses somewhere between that of Saturn and Jupiter, and they remain entirely unseen, detectable only by the magnificent patterns they have carved into the dust around them. We are like archaeologists inferring the existence of a lost city by the shape of the foundations hidden beneath the soil. But this elegant analogy of the pond and the walkers does not account for the other major feature, the Great Dust Cloud. The remnant of the collision. This feature is not a neat ripple, it is a splash. It's as if, while our walkers were creating their perfect concentric waves, someone suddenly threw a massive, jagged rock into the pond. The resulting chaos, the splash and spray, disrupts the elegant pattern. This is the central paradox of Fomalhaut. The system bears the unmistakable fingerprints of both serene, long-term gravitational sculpting and a recent violent, disruptive event. It is a cosmic ballet and a train wreck happening in the same place at the same time. This discovery forces us to reconsider how planetary systems evolve. We often think of planet formation as a relatively orderly process. Dust gathers into pebbles, pebbles into planetesimals, planetesimals into planets, all in neat, stable orbits. Fomalhaut screams that this picture is too simple, too clean. It suggests that the modern era of a solar system long after the main planets have formed can still be a time of incredible violence. The architectural phase is not necessarily over. Planetary systems are not static museum pieces. They are living, breathing, and sometimes self-destructing environments. The collision that created the phantom Fomalhaut b was not a minor fender bender. Calculations suggest the impacting bodies were the size of large asteroids like Vesta or Pallas in our own solar system. The energy released would have been equivalent to trillions of nuclear bombs. This was a world-building, or rather world-destroying event, and it happened recently in cosmic terms, likely within the last few 100,000 years. In a system that is over 400 million years old, this is akin to a major earthquake happening just a few seconds ago, in the lifespan of a century-old building. The implications of this discovery ripple outward far beyond the Fomalhaut system itself. It gives us a profound insight into the history of our own home, our solar system. We have long suspected that our early history was also incredibly violent. The leading theory for the formation of our own moon involves a similar, but even larger catastrophe. The giant impact hypothesis suggests that a Mars-sized protoplanet named Theia collided with the early Earth. The resulting debris from this colossal impact was thrown into orbit and eventually coalesced to form our moon. The craters that cover the Moon, Mercury and Mars are further testaments to a chaotic past, a period known as the Late Heavy Bombardment, when our inner solar system was a cosmic shooting gallery. In Fomalhaut, we are not just looking at a distant alien star system, we are potentially watching a replay of the same violent processes that shaped our own world and gave us our moon. JWST is providing us with a ringside seat to the kind of cosmic demolition derby that was common in our own youth. It is a window into our own past, a glimpse of the chaos from which our own relative stability eventually emerged. This makes the Fomalhaut system an invaluable laboratory. By studying the composition of the dust in these newly discovered rings, we can learn what those colliding planetesimals were made of. Was it mostly ice-like comets or rock-like asteroids? This will tell us about the raw materials available for building planets in the outer regions of that system. By tracking the subtle warps and clumps in the rings, we might even be able to pinpoint the exact location and mass of the unseen shepherd planets. We could, in effect, discover new worlds not by seeing them, but by meticulously mapping the gravitational footprints they leave behind. The future of the Fomalhaut system is an epic story waiting to be written. The great dust cloud, the ghost of the collision, will continue to expand and disperse. Over millions of years, its fine powder will spread out, some of it falling into the star, some being blown away by stellar radiation, and some slowly settling into the intermediate dust ring. The phantom of Fomalhaut B will truly and finally vanish its substance, recycled back into the system. The unseen planets, the great gravitational sculptors, will continue their silent, patient work. Their orbits will remain stable for billions of years, tirelessly maintaining the exquisite architecture of the rings they have created. But is the violence truly over? The collision we witnessed is likely not a one-time event. The very existence of such a massive dust disk implies a huge population of comets and planetesimals. The system is likely teeming with these smaller bodies, and the gravitational stirring of the shepherd planets could easily send more of them onto collision courses in the future. Fomalhaut may be destined for more such cataclysms. Perhaps in another million years, another bright cloud of dust will appear, fooling the telescopes of a future civilization. The system may be in a constant state of demolition and reconstruction. This revelation forces upon us a profound philosophical recalibration. We are biased by our own solar system, which is for the moment a place of remarkable stability. Our planets move like clockwork on predictable paths. But this tranquility may be the exception, not the rule. The universe may be a far more chaotic and violent place than our quiet neighborhood would suggest. Fomalhaut teaches us that even mature solar systems can be arenas of breathtaking destruction. It reminds us that stability is not a given. It is a precious and perhaps rare state of equilibrium. This has deep implications for our search for life elsewhere in the universe. We look for planets in the habitable zone, the region around a star where liquid water can exist. But the stability of that zone is just as important as its temperature. A world in a system as dynamic and collision-prone as Fomalhaut would face existential threats on a regular basis. Life might struggle to gain a foothold in a place where planet-sterilizing impacts are a recurring feature of the landscape. The story of Fomalhaut is therefore a cautionary tale. It is a reminder of the cosmic fragility of worlds, including our own. The empty space between planets is not truly empty. It is populated by the remnants of creation, and sometimes those remnants are set on paths of destruction. What comes next in this unfolding saga? The James Webb Space Telescope will undoubtedly continue to monitor Fomalhaut. Every new image will be scrutinized for the slightest changes for new clues to the system's secrets. Astronomers will use sophisticated computer models to try and replicate the system's unique structure. By plugging in virtual planets of different sizes and orbits, they will try to find a configuration that perfectly matches Webb's observations. This process of reverse engineering a solar system is a monumental task, a cosmic game of chess where the pieces are invisible and only their influence can be perceived. The hunt is on for the unseen architects of Fomalhaut, and there is always the possibility of yet more surprises. If Webb has shown us anything, it is that the universe consistently outpaces our imagination. What other structures, what other faint ghostly rings might lie hidden in the data? What other tales of creation and destruction are waiting to be read in the dust? We began this journey with a single lonely star. We found a celebrated planet, then lost it, revealing it to be a ghost. And now, with our most powerful observatory, we have uncovered a hidden masterpiece of cosmic architecture, a system of nested rings maintained by invisible worlds, a system scarred by recent cataclysmic violence. The story of Fomalhaut is the story of science itself. It is a journey from simple observation to complex understanding, punctuated by moments of profound shock and revolutionary insight. It is a testament to our relentless drive to look deeper, to see more clearly, and to ask more challenging questions. We thought we were looking at a simple portrait, but we have found a palimpsest, a cosmic manuscript where new stories are constantly being written over the faded text of older ones. The lonely fish is lonely no more. It is the sovereign of a complex, dynamic, and beautiful court of hidden planets and ethereal rings. It is a system that holds the secrets of our own past, and perhaps a warning about our cosmic future. And as the golden eye of Webb continues its silent vigil, we wait. We wait for the next photon, the next piece of the puzzle, the next shocking revelation from the haunted, magnificent realm of Fomalhaut. The ghost story is not over. A new chapter has just begun.